The concept of a Bernoulli trial, like flipping coins. You have some basic experiment that has, we'll start with 2 outcomes. You can do it with more outcomes. Probability of success is some value p, and the probability of failure is 1 minus p, and people often denote that with a symbol q. But then the experiment is repeated over and over again, a total of n times. But it's very important that the one trial doesn't affect the outcome of other trials. And let me give you an example. If you flip a coin and you say success is ahead and failure is tails, that's a Bernoulli trial. The result of flipping one coin doesn't affect in any way subsequent flips. Suppose you draw a card out of a deck of cards and say success is it's a red card, hearts or diamonds, and failure is it's a black card, clubs or spades. Is that a Bernoulli trial? Not unless you put the card back in and reshuffle the deck. If you pull out the card and look at it and say it's red or black, success or failure, now put the card back in and shuffle it thoroughly, and now do it again, and you keep doing that, then that's a Bernoulli trial. But if you pull the card out and say red or black, pull out another card, red or black, that's not a Bernoulli trial, because results, early results, influence later results. In particular, eventually you'll run out of cards. But a whole bunch of reds begin to bias it in favor of blacks, and vice versa. So Bernoulli trials, you're going to repeat an experiment. You're either going to get success or failure, but very important that the trials are independent. A fair coin is tossed, a pair of dice are rolled, and this is actually a pretty good example. A pair of dice is rolled, and it's success if you get an even total. Are you more likely to have a success or a failure? What do you think? Yeah, even, odd, the same, isn't it? Are you sure? Why don't we pause right here and you tell me, are you more likely to get even total or an odd total in a roll of a pair of dice? And remember your 2 extremes, 2 and 12, they're both even, but they're also the least likely. You think it's more likely to be odd? You think so, or did you calculate it? Calculate it. Calculate it. More likely to be even or odd? The even totals are 2, 4, 6, 8, 10, and 12. The probability of a 2 is 1 over 36. The probability of 4 is 3 over 36, because you can get 3, 1, 2, 2, and 1, 3. The probability of a 6 is 5 over 36, because you can do 5, 1, 4, 2, 3, 3, 2, 4, and 1, 5. So, and probability of 8 is the same as a 6. Yes? No?
For the 4, why don't you count the 2 twos twice, like 2 in the first die and 2 in the second die?
It's a good question. Let me try to answer it this way. Paint the die. Have a red one and a blue one. Roll them. Now, just look at the 2 dice. Either the red one is a 3 and the blue one is a 1, or the red one is a 2 and the blue one is a 2, or the red one is a 1 and the blue one is a 3. But there's no 2 and 2 and 2 and 2, because I can tell the difference between the red one and the blue one. You believe me? Sure. Okay. What do those numbers add up to? Point made. Wasn't obvious. Okay, Bernoulli trials. And now I give another example. 2 cards are drawn from a deck. Success is that they come from the same suit. Now success is now much less than a half. But again, I comment, in order for this to be a Bernoulli trial, before you repeat the experiment, you have to put the 2 cards back in and then reshuffle the deck. Okay. Now, here is an important formula that says if we have Bernoulli trials and we make a total of n trials with the probability of success being p, then the formula for the probability that exactly m of the trials are successes is the binomial coefficient c, n, choose m, times p to the m times 1 minus p to the n minus m. So we go back to the example on the previous slide. A fair die is rolled 10 times. The probability of getting a 3 exactly twice is C 10, 2. Out of the 10 trials, have 2 of them be 3. The probability of getting the 3 is 1 out of 6, so 1 out of 6 squared. The probability of not getting a 3 is 5 out of 6, 5 out of 6 to the 8th. I actually calculated that, and it's 1,953,125 over 6,718,464, and that's about 0.29071. Once again, my comment about big arithmetic is very applicable here because I'm working with 10 flips, 10 rolls. If I did this problem with 100 rolls, the numbers are going to be huge. Okay, trust me that my arithmetic is correct, or at least Maple tells me. Okay, another example. If you flip a fair coin 10 times, the probability that you get exactly 5 heads is C 10 choose 5 over 2 to the 10th. Now notice that in that formula at the top of the slide, if p equals 1 minus p is a half, then it's 1/2 to the n times 1/2 to the m times 1/2 to the n minus m, and that's just 1/2 to the n. So the formula is even simpler when p is 1/2. So if you want to get exactly 5 heads in a roll and 10 tosses, the probability is C10 5, which is 252, over 2 to the 10, which is 1,024, and as a decimal, that's about 0.24609. I wouldn't want to calculate any of these completely by hand because the arithmetic can get quite large.